Hello and welcome to Morse's Math Morsels. And this is among everyone's favorite topics in basic algebra, polynomial division, or the division of some polynomial by some other polynomial. And I just love this stuff. So, here in an example of one polynomial being divided by another. The variable is x. And across the border in the middle is a similar division problem, but in each case, wherever there was an x, I put in a 10. And notice a dot here between the 7 and a 10, that's really a multiplication. Well, that's a dot in the middle, that is not 7.10. So, which shall I do first? I am going to do this right side expression first. 10 plus 3 is a divisor. The dividend is 10 squared plus 7 times 10 plus 12. And equivalently in the left side, x squared plus 7x plus 12 is the dividend, that which is being divided. And there's the divisor x plus 3. If you work out the arithmetic for this problem, you get these numbers. 182 divided by 13 is 14. But here I'm just letting x equal 10. So, we have a 10 squared here and a 10 there. We're going to start with each of these 10s on the left side of each expression. How many 10s can go into 10 squared? And whatever we do with that, the plus 3 must follow along because a 10 is attached to the 3 with the addition. Or what times 10 will be 10 squared? Well, 10 will be, so we're going to put a 10 up here above this symbol, which incidentally is called a vinculum. V-I-N-C-U-L-U-M, vinculum. Well, 10 times 10 is 100. I'm going to represent that as 10 squared. But we need the plus 3 as well to ride along with the 10. 3 times 10. I'm just going to show as the 3 times a 10. And just like with the long division you learned in arithmetic, when you subtract, 10 squared minus 10 squared is 0. I'm just going to leave that blank. 7 times 10 minus 3 times 10, I'm going to represent as 4 times 10. 7 times 10 is 70, 3 times 10 is 30, and 70 minus 30 is 40. Which is just 4 times 10. And our plus 12 needs to ride along. Alright, next step. How many 10s do we need to multiply to get 4 times 10? How many 10s go into 40? Well, 4 of them. We need to add a plus 4 because this is a positive 4 times 10. And to make that clearer, that's not a t, this will remove that plus sign. We don't really need it because it is positive. Oh, 4 times 10 is 40. I'm going to represent that again as 4 times 10. And the 3 has to ride along. The plus 3 times the plus 4 is a plus 12. And voila, 4 times 10 minus 4 times 10 gives 0. 12 minus 12 is 0. And there's our quotient, 10 plus 4. Oh, so far so good. So that arithmetic worked out. Now let's compare it as I move to the left side with the left side polynomial. X plus 3 going into x squared plus 7x plus 12. How many x's do you need for an x squared? Well, x times x of them. X multiplied by itself is x squared. Well, we're going to need the x up here. And the 3 has to ride along. The 3 times the x, 3 times x is 3x. Now subtract these. The x squared minus the x squared is 0. That can stay blank. 7x minus 3x is 4x. In basic algebra, if you're subtracting some x's from x's, just subtract the coefficients. These numbers in front are called coefficients, and keep that 4x in this case. And this 12 has to come down for the ride. And I don't need that plus sign any longer. I keep doing that. Alright, how many x's do you need to multiply together to get 4x? 4 times some number versus some number. Well, you need 4 times that number. I don't need that line there anymore either. I need room. X times 4, well, this is going to be a plus 4 because this 4x is positive. X times 4 is 4x. And we need to multiply the 3 by the 4, and that's 12. And subtract that new expression. Oh, 4x plus 12 minus 4x plus 12 is 0. Well, there's our final quotient. Again, no remainder. And note the comparison of the x's on one side with the 10's on the other. So this is one way to look at and get an introduction to polynomial division. Try out a comparable problem using arithmetic. Use some easy numbers such as 10 in place of x, and set up a sample problem much like this. Thanks for viewing.